This example asks us to negate the statement, for all real numbers x, there exists a real number y such that x times y equals 0. I'm going to do this in steps. The first step I'm going to do is I'm going to write this symbolically. So for all real numbers x says for all x, there exists a real number y. There exists a y such that x times y equals 0. So the second thing I'm going to do is I'm going to write the negation, and then I'm going to write it in English. So I want to negate for all x, there exists a y such that x times y equals 0. Now, this is logically equivalent to, think about how we do negations. If you negate for all, it becomes there exists. So if you negate a universal, it becomes an existential. And then the negation kind of goes along to the next part. So this is, there exists an x such that it is not the case that there exists a y such that x times y equals 0. This is logically equivalent to there exists an x, and now I am negating this existential quantifier. You negate an existential, it becomes a universal. So for all y, it is not the case that x times y equals 0. Well, this is equivalent to there exists an x such that for all y, well, if it's not the case that x times y equals 0, that means x times y is not equal to 0. And so that's how you go through with the keep passing the negations along. And then for the third part, all I'm going to do now is I'm just going to translate this negation back into English. So this is saying there exists a real number x such that for all real numbers y, x times y is not equal to 0. And so that's how you negate those. Now, just for fun, let's think about what the truth values are here. The first one says, for all x, there exists a y such that x times y equals 0. Well, this is true. Just take y to be 0. Now, look at this negation. There exists an x such that for all y, x times y is not 0. Well, this one's false because you can always take y, in this case, y to be 0. So notice that if my original statement is true, if my original one is true, then the negated one is going to be false, which that matches what we said all the way back to the beginning of logic when we had basic propositions. That if you start out with a true proposition, its negation is going to be false. Well, that still holds true even when we have all of this complicated, nested quantifiers and negating them like that. This basic stuff still holds true. If the proposition is true, then its negation is going to be false.